Conic sections, kids, these are amazing.
Yeah, totally.
Because if you take an ice cream cone and put it on top of another ice cream cone,
like
get
a
that out
waffle,
of the way. Yeah,
like,
yeah,
a
like a waffle cone.
Waffle over waffle.
Yeah, and then you
like
take
this.
a plane, like a sheet of paper.
Yeah.
And you make
cut
some
it.
slices.
Yeah.
You get all these different shapes.
Yeah, so what in this first one, and it may be hard on your note packet to really tell what's going on. This first one,
that's a parabola shape.
That's a parabola. If you look at just like the small different color, that's a parabola. These two, if it's like a perpendicular situation to the cone, then it's a circle.
Right?
But if it's slanted,
if it's a little tilted,
it'd be an ellipse. And then this one right here is a hyperbola. And in Algebra 2, I believe you're
go forgetting one too. If you go right down the side of the cone through both cones, that's a line.
Right. These are.
And if you go through the very middle where the cones touch, that's a point.
That's true.
We can get all of the different types of ways to graph basically in 2D from this. I think that's fascinating.
It is pretty cool. So we're gonna, during Chapter 8, look at these different kinds of conic sections, and the three ones we're gonna focus on are the parabola, the ellipse, and the hyperbola. And there is actually kind of another one, the circle, but we just are going to talk about ellipses, and if it's an ellipse that it goes out the same way both directions, then it's a circle.
Right.
But
so
we're not going to make
we'll pull that in
as
part of our discussion.
Right. So we're starting off in 8.1 with a parabola. A parabola is the set of all points in a plane equidistant from a particular line called the directrix and a particular point, the focus in the plane.
Now, before we go and have a panic attack about all this directrix focus business, a parabola is still a parabola that you learned about in Algebra 1.
Like y equals x squared?
Yes.
Still the same deal.
Still the same deal.
We are kind of complicating it a little bit more because we want to know actually what's going on.
We want to define how it does this.
Right. And so what happens is you have the vertex we should be really familiar with. It's the bottom point, and it creates this symmetry on either side, this axis of symmetry that's in green here. And then the two things we may not be as familiar with are the focus is over here inside of our parabola. So if it's facing up, it's inside.
It's like the point that the parabola lines bend around.
Right. And so, and then the directrix here is going to be somewhere below that, like on the opposite side of the focus.
And it's the exact same distance from the vertex to the directrix as it is from the vertex to the focus.
Right. So like if this was a 2 here, then it would be 2 here.
Right.
That's happening. And I'm trying to remember, like, what happens is, and you can find cool applets to do this, like this point right here should be the same distance if we go here and we go here.
Right.
Like, there's these cool applets that maybe we can show at
I'll
some
see
point
if I have something on my computer. Maybe we can screenshot it and talk about it.
Yeah, yeah.
Okay.
So, like that should be the same. Like, if this was 5, this would be 5.
Right.
That's the same distance, and that's how the parabola actually gets drawn.
Right, right. Very cool.
Yes. So, and that different stuff is all in there. So the axis of symmetry here, it's called the focal axis.
Because it runs through the focus.
Yeah. So let's look some more. Let's
do
what's going on next.
Oh, looky here.
All right. So let's first start off talking about parabolas with vertex 0, 0. When we talked about parabolas at the beginning of the year, we were only talking about functions, which are y equals some sort of x squared. Right. And now we're talking about all parabolas, so they might not be functions, which means we could have
x
y squared.
Yeah, we could have y squared or x squared or some sort of
combination. Not combination. That wouldn't be a parabola.
Not yet. Wouldn't be a parabola. Okay.
So our standard form for our equations is we can have x squared equaling, and we have 4py, which p we'll talk about in a second. Or we could have y squared equaling 4px. And so depending on which term is squared, that's how you know if it opens up or down.
Right.
And then the sign actually will tell us whether, of those two things, whether it's up or down.
Yeah,
because if we had like x squared equals negative something y, then that's going to be going down.
Right.
And if we had x squared equals positive something y, it'd be going up.
up.
So the focus, we can figure out, basically, if we can figure out what this p-value is, that tells us where our focus is located, and depending on which kind of equation is which
way
place
you move.
we put it. And then the directrix can also be found using that. So
and the directrix is a line. So in case you didn't catch that on the first picture,
slide.
it is a line.
So it's like y equals or x equals.
Right.
And then the axis, if we're at 0, 0, is going to be the y-axis for the first one, the x-axis for the second one. and it'll move whenever we don't have our vertex at 0, 0. So P in all of this is our focal length, and so that P is, we might later on be able to see what that P value is later on when we're graphing.
But that's the distance from the focus to the focus.
Focal width.
Vertex to focus. That's the focal length.
Okay, and then the focal width, let's go back to this, the other picture. The focal length, we're saying, is how far it is from the vertex to the focus?
Right, because the focal width is the distance through the parabola, through the focus, from side to side.
So I can't really get rid of what I have, but
Right.
let me change colors here real quick. So our focal width would be if we took the line that goes through the focus.
Right, and it started on parabola, it goes through the focus, stops on parabola.
Right.
That's your focal width.
And then our focal length would be this 2 here that I had drawn.
Right.
That right there.
Yeah.
All right, so let's do, for example, 1. Find the focus, directrix, and the focal width of each parabola. Well, all 3 of those things revolve around knowing what P is. So that's where we should start, right?
Yeah, got to start with P. Now, I would say also, maybe where it has the standard equation, an alternate way to show that would be to divide 4P on both sides. And then you actually have the equation you would use to graph.
Right, so we could
instead
look
of saying
at
x squared equals 4py, we could say 1 over 4py times x squared equals y.
You mean 1 over 4p equals x squared. You put a y in there that wasn't supposed to be in there.
Oh, sorry. Yes.
So he's saying we could have 1 over 4p x squared equals y.
Right. If we wanted.
And it all depends on like which kind, like what your formula is. Because like this, we need to just compare this. X squared equals 4py. That's our standard form. They gave us x squared equals 8y. So what does 4p equal?
4p has to equal 8.
It does, because this and this have to match. So set 4p equal to 8, and that means that p is 2.
The deuce.
Yeah. So if p is 2, now we can go in and plug into our table and figure out what the focus, the directrix, and the focal width are. Keeping in mind that because it's x squared, we're going to use this first column the whole time. So our focus is going to be 0, p, which is 0, 2.
Right. So that's how far the focus is from the vertex.
Our directrix
goes the other way now.
Y equals negative p.
Negative 2, yep.
And then our focal width
would be 4 times that.
And it's in absolute value. So if we had a negative situation, then we would take the negative away, because we're just talking about a distance.
Just a distance.
So 4,
and we already had 4p, it's 8.
So
like that was where we started.
Yeah. So this right here is our answer. And I abbreviated those, and you can feel free to as well, unless we run into something where we can't abbreviate.
Right.
Which I don't think it should be
I don't
an
think
issue.
it's going to happen here.
So let's do part B. So this is where...
Oh, by the way, the x squared, that one's going to open left, right.
Yes. No. X squared opens up and down.
Oh, that's what I meant. The next one opens left, right.
Yes, this one opens. So, and if we write the second equation, like he mentioned, where it's x equals, then we'd have 1 over 4p y squared equals x. And that may make more sense for this equation, because look at what we've got. We've got negative 1/6 y squared. So if we compare this, we're comparing negative 1/6 and negative 1 over 4p.
Right.
So...
And in this case, the ones are equal to each other, so we really just need to set the denominators equal.
Right.
Negative 6 equals
4. Or
4.
cross multiplying will give you the same thing.
Yeah, or cross multiply.
Whichever. So negative 4p equals 6. Or you put the negative on either side of
Doesn't
that.
matter,
Doesn't
because
matter.
it's going to wind up only on one side at the end.
So p equals, if we simplify, negative 3/2. 6 over 4 is 3/2. So now let's plug those in, and now we're using the second column because we have x equals, not x squared.
Right.
And so which way would this open?
So I believe this is going to open to the left.
Right, because that's the negative direction
That is
for
correct.
x.
Right, and the p,
we've got a negative.
Our p actually moves negative 3/2. So if that focal point is what the curve bends around, and it's on the left-hand side of our
vertex,
which
is at 0, 0,
which is at
then
0,
yeah,
0, then it's got to
open.
open to the left.
So our focus is negative 3/2.
0.
0.
Yep.
And then our directrix again, we're just plugging into these values on our table. So a negative p, negative 3 halves.
Would be positive 3 halves.
Got a little change action going on there.
Click, click. And then 4p is actually where we started.
Right.
So that would just be 6.
4p would be, well, it's 4 times negative 3 halves with the absolute value, right?
Right.
Which is
6.
6. Right. Because that's 12 over 2.
Right.
Okay.
12 over 2 or 2 times 3. And remember, with focal width, it will never be negative because it is a distance.
It's a distance.
Just like if we were to get in our car, it doesn't matter if we drive in reverse or if we drive in forward, the odometer will only roll up.
So then should our focal length be an absolute value as well, or because that's
No,
a
because
distance?
yeah, but the focal length, we need to know which direction to go so that we know which way our curve bends.
Okay.
So that has to be negative.
Okay.
Okay, now what happens if we're not centered at the origin?
Yeah. What if perhaps we're centered at a point h comma k, and that h and k is going to be a recurring point of interest for us. Like for circles, ellipses, and hyperbolas, it's the center point.
And you know what? It's the super secret opposite society.
Right.
Yeah.
Because if you look here we've got parentheses, and so
inside parentheses, you got to do opposite
you
what
got
it
it.
says.
So if this is x minus 2, h is actually a positive 2.
Right.
Or if it's x plus 2, well, h would actually be a negative 2.
Right.
This is basically the same information.
Except we're centered at a different spot.
Right, and so we're having to basically, in the other one, we would have had 0 plus or 0 minus whatever
Yeah, it
values
didn't matter.
were. And so now we have to put in the h and the k.
Okay, let's dig
There you
in.
go.
Come on.
So find the focus direction, focal width of each parabola. So this is the second column.
Right, because we're squaring the y.
So the focus, well, do we need to find the vertex? We should probably find the vertex.
I mean, vertex
That's
is,
gonna be helpful.
we need the vertex,
The
which
vertex
is
is
negative
going
5,
to be,
2.
Right, because the x part goes in the x,
And the y part goes
in
with
the
y.
And
Yeah.
that should be familiar to what we've done.
We've done
did
this
with
1,000
vertex.
times. So if you've, honestly worked your homework, that shouldn't be a problem right there.
All right, so our focus then takes h plus p comma k.
We got to find p. Let's find p.
What's p?
Well, 4p is equal to 3.
Right, this part right here in front of our
Yes.
parentheses. So if 4p equals 3,
Wow, you write so tiny.
I can sometimes. P equals
3 fourths.
Good thing you're up close to the screen, huh?
That's right. That's right.
So that means that we need to do h.
Now this is opening up and down, so we need to go. It's got to go up or
No,
we're
it's
opening
left
left
or
or right.
right.
So we're going to actually add this number, since it's positive, to the x value.
Right. So negative 5 plus 3 fourths, comma 2. And if I get a common denominator here,
That's going to be 20.
negative 20 over 4 plus 3 is negative 17 over 4, comma 2.
Righto.
So that's our focus. How about our directrix?
So directrix is the line x equals, but now it goes on the other side. So where we just added 3 fourths to negative 5,
Now we're going to do...
now we're going to subtract.
So negative 5
Minus
3
3
fourths.
fourths.
And so that's negative 20 fourths minus 3 fourths,
It was
which
minus
is
23.
fourths.
And it's a line. It's a line. It's not a point. It's a line.
So
The line,
equals
x equals. Yep. And then 4p, that's where we started to begin with.
So 4p was 3.
It was 3.
So the absolute value of that's still 3.
Yeah.
So our focal width is 3.
Yeah. Focal width part shouldn't be tough, because usually 4p is what we're given to start.
Yes, a lot of times. But
A lot
like
of times.
here,
But not every time.
Here, see, that's not happening. So to me, and we didn't do this on the last one. Let me find a good color. Okay, so to me, because of the way our standard form is, I would recommend we get this over to this side. And before we do that, let's put parentheses around this. We don't want to mess it up. If I want to move this negative 1/4, then I would multiply both sides by a negative 4.
Right.
So we can rewrite this as x plus 4 squared equals negative 4 y plus 1. And now
Hey, we're in
we
the
know
form.
what 4p equals.
Yes.
So let's start with our vertex, though. Our
Vertex is negative 4, negative 1.
Right.
And remember,
x goes with
yep,
x.
Yep,
Y
every
goes with
single
Y.
time.
And super secret opposite
That
society.
is correct.
Okay, our focus
So the focus is going to be.
Now we're on the first column, right?
Right.
So we're going to add to our y.
So
not
we got
our
to
x.
find p.
Oh right, p here. This is 4p. 4p equals negative 4.
So p is -1.
That's correct.
Yep.
Because you divide both sides by 4.
Right.
So that means that I
Can
am
you
going
spell
to.
cup?
No.
Ah.
K plus p is -1 plus -1.
That's -2.
That is -2. So I'm just writing it out just for kicks and giggles. So -4, comma, -2. That's where our focus is at. And what do we got now?
We need the directrix. So now we're going to go the other way. So where we did have -1 plus -1, we're going to do -1 minus -1, and it's a y equals situation.
Oh.
What are you doing?
Nothing?
Y equals.
Okay, y equals, for the directrix, k minus p. So
-1 minus -1.
minus a -1.
Oh, I see what you did there.
So our line is y
Y
equals
equals
0.
0. So it's the actual axis, the y axis, yeah.
The x-axis.
4p. That's 4, because the absolute value of 4p is the absolute value of -4, and the absolute value of -4 is 4.
I couldn't agree more.
Of course you can't. I'm finally right.
With these, we can write the standard form of a parabola when they give us a ton of different information. So
Let's practice.
We're gonna practice because one problem may give you one thing and you do it one way, and then the next problem gives you something else. And it's like, whoa, what do I do there?
They didn't give me the vertex.
So it's really helpful to have the charts so that you can look at them, because that's what we're going to be using to help us. So
even your teachers got the charts.
Yeah, we got the charts here. So if the vertex is at 0, 0, look at the chart for 0, 0.
Which is on the left.
Well, not on their note packet, but in your book it would be on the left side.
Yeah.
So if our focus is -3, 0, it has to be y squared equals 4px.
Because we're looking at what's different. Where does the focus show up? Like what value changes, x or y? And that's your visual cue as to which side to work with.
Yeah, because this is p, 0. So
Right.
that means that our p is -3, which means, oh look, we just put it in there.
Oh look. If you could
So
draw an
4
equal sign.
Hey, it's your computer. It's not
How
me.
dare you talk bad about baby
Do you sometimes put your computer in the corner?
when he's naughty?
Okay.
Now how hard was that?
That was not hard at all. So, B. Now we've got a focus of 0, -4 and a directrix.
Okay,
at y
I know
equals 4.
I know exactly what to do.
Okay.
Okay, so if the focus is the same distance from the vertex as the directrix is, and we know that the focus has a y-coordinate of -4 and the directrix has a y-coordinate of 4.
Then our vertex has to be in the middle of that.
Then our vertex has to be in the middle.
So that means our vertex is at 0, 0?
Yes, because the x-coordinate won't change on that. The only thing changing is y. And the only thing that's changing is y. I know that because it says y equals 4, and the point has a -4 for the y. Nothing else changes.
Yeah, and so if we look at our chart, that means we're in the first column because we've got 0, something, and we've got y equals something.
Right.
And so from this, we know that p is -4.
Right.
Because the directrix has a -p, and that makes sense. So our standard form this time is to have x squared equals 4py. So we just need to put in -4. So
X squared equals -16y.
-16y.
I love these kinds of problems. They're just fun. How could you not like this as a mathematician?
I don't know. Vertex is 0, 0. It opens downward, so that tells us which column to look at.
Oh, and it also tells us what p is going to be. P is going to be negative.
Exactly. So, and that's helpful because this focal width is 6.
That's 4p.
And it's the absolute value of 4p.
Right.
And so this could end up being either a positive 3/2 or a negative 3/2, but because they told us it opened downward, we know it needs to be negative.
Yeah. If you open left or down, p is going to be negative.
Yes. So now that we know what p is, and we're in the first column, so we have x squared equals 4 times -3/2 times y, and then we just need to simplify this. That's 4/1, so that's going to be
-6.
And so x squared equals negative 6y.
And remember, 4p is equal to the focal width. So on this one, they gave us focal width.
Yeah, totally.
Yeah.
So our standard form, by the way, notice that we're not solved for y and we're not solved for x.
No,
and
we're
that
good.
may be a little uncomfortable, but technically for our purposes in this chapter, that is considered standard form.
Right. And if you are one of those kinds of OCD kids and you can't handle it, just divide both sides by negative 6. It's the same thing.
Yeah.
But you don't have to. Like, you
Right,
don't
just
have to
leave
take
it.
that step.
Just
So we're
leave it.
giving you permission to leave it.
All right. So our focus is at negative 5 comma 3 and our vertex is at negative 5 comma 6. So our x's, well,
The x's don't change. The
for-
x's don't change.
The x's don't change, but also our vertex is not at 0, 0. They
That
told
is
us our
correct.
vertex.
Right.
So we know that we're going to have some kind of a parentheses thing going
Right.
on, right?
Right.
But so the x's didn't change from our focus and our vertex.
So our vertex is negative
So-
5, 6. So we just need to figure out if the x coordinate doesn't change, but the y coordinate does, that means that it's got to be opening left or right.
Up or down. The x didn't change.
X didn't change. The y coordinate does, so it opens up or down.
Yes.
That's what I said.
Yeah, totally.
Totally was. So
And look at your
that's
chart
that's
where-
a y squared. That's an x squared situation. That's an x squared situation.
Because what's happening here is this is h comma k plus p. And I know that because this is h. Ooh, that's not an h. This is h comma k. That's our vertex is h comma k. Our h didn't change. Our k did.
Right.
Okay, so that tells us we're in the first column. So this will be an x. This will be a y. And we can fill in our vertex. Go ahead.
X plus 5, super secret opposite society, but a better looking 5.
Yeah.
That's a
No-
good 5.
no doubts.
That's a good 5.
And then y.
Minus 6, super secret opposites.
Right. So now we just have to figure out what P is. So
I know.
Yeah.
Well, if the vertex starts at 6 and the focus goes to 3, how far do we move from 6 to 3?
That's a great question. How
3.
far did
We move 3 units.
Okay. And so it's kind of this situation going on right here that K is 6 and K plus P is 3, which means you'd fill the 6 in here.
Right. And then you got a little
subtract.
single step algebra 1 problem.
But it's important that we make sure we get the right sign, right? This is
Right.
P equals negative 3.
Right. Yeah, that's
Which
important.
it opens.
Which means it's going to open down now.
Okay.
So.
Yeah. I don't know if you mentioned that earlier or not, but. So 4 times negative 3 makes this negative 12. And then here we have our focus is 3 comma 4. Our directrix is at y equals 1. If our directrix...
Okay, directrix is a horizontal directrix, which means that it's going to open up or down.
Left
so-
or right?
If y equals 1 for the directrix, so if y equals 1 for the directrix,
Oh, I was looking at the axis. You're right. Okay, sorry. My bad. I was looking at the axis.
hey, can we just, while this is rolling, could we just get a...
You were right.
Yes.
Okay, let's not make a big deal about it. Okay, so our focus, if we have y equals 1, our focus then has to be h comma k plus p, and our directrix would equal, or is y equals k minus p.
So here's the deal. How far do we go from 4 to 1? That's the question.
3.
So halfway through is where the vertex is going to be.
Okay. And so, and if that is difficult, I mean, you can actually set these equal. Like, I know h has to be 3.
Right.
I know that 4 has to be k plus p. And I know that 1 has to equal k minus p. And then look, you've got this really simple elimination problem.
Two equations with 2 unknowns.
Yeah, so 4 plus 1 is 5. K plus k is 2k. P minus p goes away, so k is, 5 halves.
Which would be 2.5.
Which would be 2.5.
Which is half of 3.
It's
Should be
a-
1.5, right? If you add 2, okay.
Oh, no. Okay, so we're between 1 and 4. Halfway between 1 and 4 is at 2.5 because you go up 1.5 and you go down 1.5.
Oh, that's right. Okay.
Okay, because it's 3 in between there. Okay, so that's why I think the solving the system is a lot easier personally, because it takes the what's going on like visually out of it.
Right.
Like this will always work to find us K and P. So if K is 5/2, you would plug it back in and solve right here. So you'd subtract 5/2 and you'd get that P equals, so 4 minus 2.5 is 1.5, which is 3/2.
3/2.
And now we've got H, K, and P, which means we have all the parts we need.
We got all the parts we need.
Which one were we on? Are we in the first column? We are in the first column.
Yeah, I believe so.
So X, H is 3, so X minus 3 squared equals 4 times P, and
4P.
P is 3/2, so that's
4
6.
4 times,
4 times 3/2 is 6.
Right.
And then Y minus K, and K was 5/2, so minus 5/2. So you are going to end up with some fractions every now and then, and we've just got to
But you know, it's
get
okay.
over it.
A fraction is not necessarily bad.
No, not necessarily.
Yeah.
Not. It's not like. Never mind. All right, our vertex is at -1, -4. That's helpful.
Okay.
It opens to the left. That's helpful.
That's a negative P.
That's a negative P, and also that means we're in the second column. Our focal width is 10.
That's a 4P.
So yeah, the absolute value of 4P equals 10, and so we'll just divide by 4 and get 5/2. But we know it's negative because it opens to the left. If they said opens right, we'd make it positive.
That's
5/2.
correct. That's correct.
Now I've got all our information. So we're in the second column.
We're opening left, right, which means we're squaring the X part.
The Y.
The Y. Gosh, I don't every time. I even said it
now
right.
Now why are you wondering why I doubted you before? So Y.
Why would you bring that up?
4 squared equals 4 times P. So 4 times -5/2 is -10.
Yes, because 4 divided by 2 is 2. 2 times 5 is 10.
And then X plus 1, because we add the X part of our vertex.
Right.
There we go.
Bingo,
and
bingo,
that was a lot,
bongo.
and you can see how it gets kind of complicated, but we just are having to focus on matching up parts of what we know to parts on the chart.
Right. Right.
So. All right, example 4, sketch the graph of the parabola
You
by
got a
hand.
Warner Brother. Just checking my email.
Warner
Sorry.
Brother?
Warner Brothers.
The
This educational clip brought to you by Warner Brothers.
Okay, so check using your grapher, but we're going to sketch it by hand because let's visually look at what all these things have, okay?
Right.
And every time you graph these, you may or may not necessarily have to have all of these parts, but let's actually take a look at like what's going on. So why don't you talk about what how you think we should get started? I'll draw an X and Y axis.
I say we need to find a vertex, because if we know what the vertex is, that's like your start. You got to know where that part is.
Yeah.
And we're given in our equation, the way it's written, we know exactly where to go for that. We go to the point -3, -2. That's our vertex. So I say let's start there. And so...
And go from there. Okay,
yeah,
so...
okay, so -3, -2. And so start at that spot. Yeah, right there. Bingo. And then...
Then we can look at the rest of this stuff using...
Everything else follows after that.
Right.
So the focal width is 4P. Well, the focal width in this case is just 16. So we can automatically fill in that part.
Okay.
Okay.
And then we know that 4P equals -16 because
Right.
that's our standard form.
So P is -4.
That lets us fill in the
Right.
rest of
And,
this.
and since Y is being squared instead of the X, since Y is being squared, this is going to be a left-right situation.
That's right. And
Okay.
so our focus is going to be...
And it's negative, which means it opens left.
Yes,
So,
it does open left.
So we would just move 4 units left from the vertex to get to our focus, which makes that -7.
Okay, so we would go 1, 2, 3, 4. This right here you're saying is our focus?
Right.
And that makes sense because we do -3 plus a -4 and we get -7.
Right.
If you look at that formula on your chart. The directrix, on the other hand, should be a vertical line, that's on the other side.
The exact same units away.
Yeah, and so we get, since it's vertical, it's x,
So
and then it's h
x
minus
equals
p.
1.
So it should be x equals 1.
Right.
Because we have, what is that? -3 plus 4. So
Right.
that's 1.
Right.
That,
And then the axis is actually going to be
Just-
the y coordinate in this case, because that's what splits the parabola exactly in symmetrical halves.
right. So let me get a couple different colors here to make this nice and pretty. So we've got
Nice and
the directrix
pretty.
at x equals 1. So that's going to be this line right here.
Yep.
And then we've got, what else?
Our
Our axis at y equals -2. So that's going to go through the focus.
Both of those puppies.
And the vertex. That's not bad right there.
Yep.
That line. And then the other thing is our focal width is 16. So that means from our focus we would go 8 up and 8 down. So
and that gives you, and then that allows you to draw your parabola.
Why'd you say it like that?
Because we're in the south, kind of.
Still,
What part of the United States is Oklahoma in?
I
Is it
don't-
like southwest, central, south central, southeast? What would you say?
I don't know.
Mid?
So from the focus we would go 8 up. That's where our parabola gets to, and 8 down, because that gives us our focal width of 16.
And so now you just complete your parabola by
So start at the vertex.
start at the vertex, get a straight line, get a curvy line. There you go. And then,
And
wow, that's really a wide one.
it is. Well, the focal width is 16.
It's a wide parabola right there.
So something to that effect.
There you go.
Obviously, that's not a perfect graph,
But you know
it
what?
looks
That
pretty
works.
good.
Looks pretty good.
Let's discuss really quick if we were to put this in our grapher, what we would have to do.
Well, I believe if you have the old TI Inspire,
Then
I
you
think you
can-
can actually just put it in. I'll check that while you explain what to do on the 84.
Right. We need to solve for y, so we have to square root both sides. So I would have y plus 2 equals plus or minus the square root of -16x plus 3. And then we just need to subtract 2. Y equals -2 plus or minus the square root of -16 times x plus 3.
Yeah, so the Inspire,
So there's two different y equals there that
the
complete
Inspire
graph.
lets you put it in either way. So you actually have a choice based on actually example 4. You could put it in as example 4 is given to you, or you could actually type it in as example 5 gives it to you. So,
Okay,
so
that's
the Inspire is very, very helpful. And
Very
all you do to
helpful.
do that is you hit the menu button from your graph. You hit the menu button and choose the graph entry edit
And go to equation.
and go to equation.
Okay.
So
Now,
bingo, bango, bongo.
exactly. So example 5 asks us to prove that the graph is a parabola. And so in order for us to do that, we need to basically get it in vertex form.
Well, I sense that there's a completion of the square
You know, it's been a while since
in
we
our
did
future.
that. It's happening right now, and it's going to happen again in this.
It's happening right now.
In this,
Is that one of them earthquakes that am I feeling an earthquake?
maybe, I don't know. So we want our y's together on the left side, and let's put our x's together on the other. So add 6x over, subtract 13 over.
Yep.
Okay, so we're completing the square on our y's because that's what's being squared.
I've got
So-
a way to remember that. Half it, square it, add it, darn it.
That's quite the, you take the number in front of y because that's what we're completing the square on, you divide it by 2, you square it, and that tells you what you're adding.
Right.
Which is what you just said. So you add 1 to both sides.
And you have to add 1 to both sides, otherwise
You're not equal.
Yeah, and that's bad news.
So on the left side here, how would we factor y squared plus 2y
It
plus
actually
1?
factors to whatever number you squared.
Yeah, so,
So
y plus
y
1
plus 1
times
squared.
y plus 1, which is y plus 1 squared. Let's add this together, 6x minus 12.
Yep.
And so to finish off, to make it be in standard form, we need to factor on the right side.
Yes, because it has to be a number times x only, not 6x. So we've got to get that. So whatever number's in front of x, doesn't matter what it is, you have to factor that out. And on occasion, that could be some weird factoring.
Absolutely, it could be. So here is our standard form. So that is us proving that this really is a parabola. And now
So
we need
y's
to find...
being squared again.
Yeah, now we need to find our
Opens
vertex.
left and right. Vertex is going to be the point 2, -1.
Our Focus.
Our focus is going to be,
We're in the second column
yeah,
right
we're in
now.
the second, back to the second column. So the focus would be the distance from the vertex to that point that we bend around. Well,
we need to find P.
Yeah, we got to find P, and it's going to move left, right.
Yes. So x equals 3/2. If we make 4p equals 6, and then divide by 4 on both sides, p is 3/2.
Right.
So we're doing 2 plus p.
3/2.
So 2 plus 3/2.
It's positive. It opens to the right.
So that gives 7/2.
That would be 4. Yes, 7/2.
Okay, that's our focus. What else? The directrix. So our directrix is y equals. No, just kidding. X equals.
No, the directrix in this case should be an x equals situation because of the
I'm
left
just
and
used
right
to saying
opening.
y equals. I
Yes.
don't even know why I bothered. So
I don't either.
h is 2, but now we're going to subtract 3/2.
Right, so 2 minus 3/2, which is a half.
This should be a constant theme that here we're doing plus and then here we're doing minus.
Right.
So x equals 2 minus 1.5
That's
is
a half.
0.5.
That's what I just said.
Did you really?
Yeah.
I'm so sorry. I didn't even know.
No, that's okay. You're used to me not saying the right stuff, so you just weren't ready.
Exactly.
By the way, we could also, now that we've done all this work, we could graph that super ease.
Super ease?
Super ease.
Like
super
by
easy.
hand?
By hand, yeah.
By hand.
Yeah, there you go. Case closed. Put that one in the books.